We've talked about this before. If something or some things are similar to each other, what does that mean? Same shape, different sizes. Exactly right. So when we did this the first time, we were comparing them by making a similarity statement. And what was important about the similarity statement? Okay, so the symbol, similar, is shown by my squiggly thing. But what was really, really important about this? If I was showing similar triangles, and for instance, they gave me something like this, and then this one went like this, how could they tell me that ABC was definitely similar to DEF? What did I have to make sure of? The letters were in the same spot, right? That the order mattered. So how did they tell us that? Well, they might do this and then make 2, 3 arcs. So what would go with A? We would assume D would go there, and E and A would go together, and then F and C would go together, right? And then, like Kenzie said, the order would matter. So not necessarily do we have to start with A. Maybe somebody wanted to start at the top and say BAC, and then she said we have to use that little squiggly mark. So if we say BAC, then we'd have to say what? EDF. So the order matters. Now, Jess didn't look at it and she's going to go ABC, then she would have had to do DEF. Right? Dave's going to start at C. He's going to take a cab. Right? If he takes a cab, then he has to do FDE. So on and so forth. What did it mean now about, obviously, my angles are all what to each other? Congruent to corresponding angles. Corresponding meaning what? In the same spot, okay? And then what else was true? In similar shapes. What was true about this side compared to this side? It was proportional, right? Or it made a ratio, okay? So we're going to use that ratio today, and we're going to then carry it on to what we've been working with. So when we did this the first time, all of our sides, so if we said AB, AB would have been to what? What makes the ratio in my other triangle? DE. And then we're going to make a proportion. So what's another group of sides? BC and, what'd you say? EF. Perfect. Now, what else was important about when I made that proportion? I had to make sure that it was the same triangle in the same spot, right? So Kenzie or whoever said it said this first one and then to this. So my second fraction and my third fraction would have to always go the bigger one to the smaller one. Okay? And this ratio then was called, do you remember what that was called? This ratio, if it was the same all the way through, was called a scale factor. I don't know if we actually said that. And so then that scale factor is what we were looking for. Well, previously we looked at it through perimeters. And what was true about the perimeter of those shapes? They were also the same proportion or scale factor. Well, this right now that we're working with is about areas, right? What's true about an area compared to a perimeter with respect to the label? The label on perimeter is just what? In perimeter. The units. In an area, the label is square. So when you do this in this section today, we're talking about areas now because that's just what this section's about. So this is what we're going to be able to write. If I still have my scale factor or my ratio, I don't want to write this. I know that my ratio with the, let's say, small over the big, it's going to be equal to, when we did the perimeter, they were the same, but now we're talking about the area of the small over the area of the big. But just like the label when we put our answer, when we set up these ratios, the areas are essentially squared for their ratio or scale factor. So when you do this today, the first ratio is still going to be the same. Exactly what you come up with. So if they tell me that this is 9 and this is x, we would make that ratio of 9 over x. Or if they told us what x was, let's change x to 6. Then we would put 6 here. And so our scale factor would realistically be 9 over 6 or what? 3/2, right? But if I'm going to do this with areas, then in order for me to find the scale factor for this, I have to take that ratio and square it. So this, the area scale factor would be what's not our 3/2 squared. What's 3/2 squared? Square both numbers. 9/4. So my ratio for my areas would be 9/4. So all you're doing is finding the scale factor and then squaring both of the numbers. And that's going to be the same scale factor that you use all the time. Okay? So you're going to use this to set up proportions in the process to figure out portions of the size. So instead of them then giving you this, and we can come back and turn this into x, they're going to say, what is x if the area of this triangle is 36 inches squared, and the area of this is 24 inches squared. And then you can figure it out, because you could use this. But if they give you areas, the first thing that I have to do is reduce it back to the original scale factor. You cannot use the squared scale factor in the problem. Okay, so you got to take the square root of the scale factor when it involves the areas. And we'll show you that in the examples. Okay? Now, would you say, when we think about regular polygons, what we did yesterday, would you say all regular octagons are all similar to each other? Would you say all regular octagons are similar to each other? If I had a stop sign and I had another regular octagon that was a smaller stop sign, are those similar to each other? They got the exact same shape, right? So think about that. When you have circles, are all circles similar to each other? Yes, right? Are all rectangles similar to each other? What's a regular rectangle, though? Square, right? So are all squares similar to each other? Yes, but are all rectangles similar to each other? No, because I could have a rectangle that's this long, but I could have a rectangle that's, this short, but then really fat. And so they're not exactly rectangles. Every rectangle is not like that little box up there, right? Not every rectangle. We can make all sorts of sizes of rectangles. But if we say that it's a square, then they're all the same. Okay? So let's look at some of this. I know this is probably confusing with the squaring and not squaring and such. So let's look at some of these, and then hopefully it'll get cleared up. But essentially, we're making proportions today. The only thing you have to realize is it a area or is it a regular ratio? So it says in ABCD, or if ABCD is similar to PQRS. So right away, you got to look at where they're talking about. Did they write the letters in order? A, B, C, D, and then P, Q, R, S. So no matter how they draw it, because they give you this order, you know that A and P have to be the same spot, or essentially the corresponding angles. And then B and Q. So realistically, the green one, they did what? Yeah, they tipped it over on the left-hand side, right? Everybody see what I'm saying there? So when we do this now, can you tell what the ratio is by the given sides in the problem? What's my scale factor of the blue one to the green one? 6/9, right? So I can write my scale factor as 6/9. And then they want us to use that scale factor and find 48 square inches. Okay, so here's the problem. When we do this, all right, we're going to have 48. And is 48 the big one or the small one? It's the small one, so should it be on the top or the bottom compared to our ratio? It should be on the top, right? So basically, we have this right here. Now, I didn't write it right here because when we talk about areas, these areas are squared. So honestly, the book does a nice job with this one. So the first thing that they want you to do is figure out what the scale factor is with the areas. So if we go back to what we had drawn out, okay, we know that we need to find out what the scale factor is for this right here. If I reduce this scale factor, what do I get? 2/3, right? So if I take this right here, what I'm getting at is if they give you a scale factor with respect to the regular sides, which this would be, right? 2 to 3 for my sides. I need to take that scale factor and square it to use it in this proportion down here where we are dealing with areas. So if I take 2/3 and square it, what would my ratio be? 4/9, right? And so we already set up our other ratio with the small one to the big one. So we're going to take the small one to the big one. But notice, I didn't use the ratio that was given to me in the problem. I have to convert it into a ratio that is squared because we're talking about areas. Does that make sense? So if they were just asking us here and they gave us another number, I don't know, let's say that this is 12. And they wanted us to find this as x. We could have went back and done what we did a couple chapters ago. And we could have set it up as 6:9 as x is to 12. But they're all lengths of the sides of the two rectangles. Here they give us an area, so I have to take this scale factor and convert it into a scale factor that is squared. And that's the difference between what we did previously and what we're going to do in this section. After you figure this part out, what my ratio is, then I just go ahead and do the math, just like what we did before. So we take 48 times 9 divided by 4, and my answer then is what? What should this x actually represent? It represents the area of the big one. Exactly right. Okay? That makes sense? Let's try it again. So, E, F, G, H, and L, M, N, O are similar to each other. And the area of E, F, G, H, which is, which one? The smaller one again, is 40. So, set up your ratio that they give you. And my ratio, do you want to do the blue to the green or the green to the blue? Blue to green. So we're going to do 4/12. And let's reduce that. Now, obviously, you don't have to reduce this before you square it. But if you don't reduce it, then your numbers just get bigger. So if I reduce this, what do I get? 1/3. And then what do I have to do with this scale factor? I'm going to square it, right? So I'm going to take that whole thing and square it. So what's 1/3 squared? 1/9. Remember, when I square a fraction, I'm just squaring the top number by itself and I'm squaring the bottom number by itself. So I'm going to take 1/9. This is my area scale factor now. And I'm going to set that equal to, Cora said we did the little one to the big one. So where does 40 go? On the top or on the bottom? The top, because it's the area of the little rectangle, right? 40 is to, and then we have our x. So what's x? Come on, simple math. 360 what? Feet squared? Well, this is where it gets all jacked up. Because look at this. In the problem, they say square inches. But then they give everything else in feet. This book sometimes gets me. I would agree with Cora though. So they just must have had that inches thing as a typo. Okay. Does that make sense though? All right. So the other way that you can do this is basically going backwards. So notice in this one right here, remember in the first two that gave you both of these numbers? Well, now they're asking you to find those numbers. So basically what you're going to do is take your areas and you are going to set up a ratio again. But you have to remember that when I set up this ratio, and again, do you want to go from the bigger one to the smaller one or the smaller to the bigger? Doesn't matter. Smaller to bigger. So we're going to do 50 is to 98. So if I look at those two fractions right there, remember now, these are areas. So my scale factor with these areas should be squared. So I got to get rid of that square. But if I took the square root of each of these numbers, would I get a whole number? Do I know the square root of 98 off the top of my head? Heck no. So can I reduce those two numbers by the same thing? 2. If I reduce these by 2, what's 50 divided by 2? 25. And what's 98 divided by 2? 49. Okay. Now can I take the square root of those two numbers? Yeah, if I take this. So if I take the square root of those two numbers, what do I get? 5/7. So now this is the scale factor that we came up with after using the areas. So this is my scale factor that I can use with my, sides that they give me of the triangle. So now we're going to set it up, and we did smaller to bigger, because Merrick said that. So we're going to do smaller to bigger. All I'm doing is taking these and putting them in the same spot that my scale factor was in. And now I'm ready to do my proportion. So what's 14 times 5 divided by 7? My answer is 10. So, does that make sense if I put 10 right there? Yeah, kind of looks like it. All right. So, do you see the difference though when they give you the areas in the problem? I have to first take them and take the square root of them. If they don't give you numbers that you can take the perfect square root of, then look to reduce it first to find your scale factor. That makes sense? Okay. You need to see another one of those kind? Or kind of asleep again? I think that's pretty much it though. Any questions with any of that? So, still got about 15 minutes. So what's on the quiz? The quiz is basically yesterday's and today's. I think. I don't think I put anything else Oh, I think in this class, the biggest thing that we had missing were vocab sheets from a couple chapters ago, maybe last chapter. So if you still have your vocab sheet, make sure it gets turned in. Yep, just those two sections for, sorry, not tomorrow, but on Thursday. We should have a whole period